This video is about the area of a trapezoid. It's found in your text in section 11-3. So what is a trapezoid? We define a trapezoid as being a quadrilateral that has two parallel sides. So let's look through these different drawings and see which ones are trapezoids. Here we have a quadrilateral, 1, 2, 3, 4. And yes, it does have two parallel sides, so that's a trapezoid. Here we have a quadrilateral. It has two parallel sides, and I should have marked a congruency here. This is a special kind of trapezoid called an isosceles trapezoid because the two legs of the trapezoid, we call these legs, are congruent. So that is definitely a kind of trapezoid. Let's look down here. We have a quadrilateral. There are two parallel sides. The interesting thing about this trapezoid is that I've made right angles here, but that doesn't change the fact that it's still a trapezoid. Okay, let's start over here now. I have 1, 2, 3, 4, 5 sides. So even though there are two parallel sides here, this would be a non-example of a trapezoid because a trapezoid has to be a quadrilateral. Let's look down here. Okay, we have 1, 2, 3, 4 sides, but none of them are parallel. So that's a non-example because we have to have at least two parallel sides. Let's look at this final one. Oh, we have a parallelogram. So can a parallelogram be a trapezoid? Well, under this definition, yes, because it is a quadrilateral and it has two parallel sides. It has more than two parallel sides, but it does have two parallel sides. So we are going to put a check mark by that one as well. Okay, here's a theorem that tells us the area of a trapezoid. First, I want to interpret the theorem for you, and then I'll give you a sketch of a proof or a way to understand it. First of all, when we have a trapezoid, we define the height as the perpendicular distance between the two bases. Now, a base is one of the parallel sides. So a trapezoid has two bases, which are parallel to each other. The height is perpendicular to both bases. And then you can just add, if you are interested, to your diagram, a note to yourself that the two other sides of a trapezoid are called legs. So if we plug in the measure of base 1 and base 2 and the height here, we will get the area of a trapezoid. But that's not very satisfying. How can we understand why this formula works? Well, the proof is somewhat similar to what we did when we studied the area of a parallelogram. We can divide up the trapezoid into two regions. Let's call them region 1 and region 2. And notice that both of these regions are triangles. I've already sketched in this vertical line here that represents the height of the trapezoid, and it also happens to represent the height of this triangle if we take this as the base of triangle 1. So area 1 turns out to be 1/2 times the base of that, so that would be B1 times the height. Okay, let's look at triangle 2. Now, suppose we pick this side as the base. I know that that's counterintuitive because it's at the top of the triangle, but remember, we can pick any side as the base. And then what would the height of this triangle be? Well, remember that we have to go to the vertex that's opposite the base. We have to extend the base, the line that the base is on, and then we have to draw a perpendicular line going from the opposite vertex to that base. Look at that. So this height of triangle 2 ends up being the same as the height of triangle 1, because with these two lines being parallel, this shape here ends up being a rectangle. And so this we can also label H. So the area of region 2 is going to be 1/2 times the base of that triangle, B2, times the height of the green triangle, which is also H. I think you might see where I'm going with this now. So the area of 1 plus the area of 2 is going to be all of this plus all of this. And rather than writing the whole thing out, I'm going to factor out a 1/2. Since there's a 1/2 in both of these, I'm also going to factor out an H. And what's left over here is base 1, which comes from region 1, plus base 2, which comes from region 2. So that's a simple little proof, a sketch of a proof for why the area of a trapezoid is what it is. Another way to remember this, though, without having to think through the whole proof, is that the height here is kind of like the height of a rectangle. And we have 1/2 of B1 plus B2. How do we make sense of that? Well, this would actually be like the average between these two bases. If we were to average the length of base 1 and base 2, this would be the average between those two. So if we were to sort of think of this as a rectangle, we could sort of think of it as being the average base length times the height. If that's not helpful to you, just forget about it. It's one way that I use to help remember this formula. Let's do an example problem. We're asked to find the area of this trapezoid. Notice that we don't have the height sketched in anywhere here yet, so I'm going to drop a perpendicular right here to form the height. And we're not given the measure of this base either, so we have a little work to do. But we are given that this angle measures 60. And this happens to be an isosceles trapezoid. So this triangle will be identical to this triangle. We have a 60-degree angle here and a right angle here. So this gives us a 30, 60, 90 special right triangle. And if you remember the way that the sides are related in a 30, 60, 90, we have the hypotenuse is 6. And the shorter leg is going to be half of the hypotenuse. So this measure here is going to be 3. Since this triangle is identical, we also have this measure being 3. And then the other leg of the triangle is the square root of 3 times the shorter leg. So it turns out our height is going to be the square root of 3 times 3, which we normally write 3 times the square root of 3. Okay, now that we know this is 3 and this is 3, and we know that the whole thing is 10, we can look at this little rectangle here and say, what must this side measure? If we take this whole base of 10, subtract 3 from this side and subtract 3 from this side, what's left over is 4. So inside here, that measure would be 4, which tells us that this measure is also 4, since this is a rectangle. So we've got all our measures written in there. Okay, so we're going to apply the formula. 1/2 of the height times B1 plus B2. So that gives me 1/2. I have 3 times the square root of 3 for my height. My long base is 10, and my shorter base up here is 4. So we're not going to get rid of this radical. We're just going to leave everything in simplest radical form. This is going to give us 14. 14 times 1/2 is 7. So we've got 7 times 3 times the square root of 3. And then 7 times 3 is 21. And we'll just leave the square root of 3 like it is. So we have this in simplest radical form. And if we had units given to us, this would be in whatever units that is squared, square units. You try this one. Find the area of this trapezoid. Now I'm going to ask you to try another one. Find the area of a trapezoid with bases 8 and 18 and 45-degree base angles. The hint that I'm going to give you on this one is that 45-degree base angles means both base angles are 45 degrees, which tells us, this is a pretty poor drawing, which tells us that, again, this is an isosceles trapezoid. So I'll let you finish labeling that diagram on your own. Let's do one more example. This time we'll need a calculator or trig table to find some of the missing parts. So again, we have an isosceles trapezoid. I'm going to drop my perpendicular line here and here. Now I have two congruent triangles here on the sides and a rectangle in the middle. 6 is going to be this portion of the longer base, but I don't know this portion and this portion of the longer base. So I'm going to call that x. X will just be this distance here. Okay, notice that x is the side adjacent to this 40-degree angle, and 10 is the hypotenuse of this right triangle. So I'm going to use the cosine function, since cosine involves the adjacent and the hypotenuse. The cosine of 40 is adjacent over hypotenuse, which is 10. So multiplying both sides by 10, I have 10 times the cosine of 40 equals x. I can look up the cosine of 40. It's 0.7660. Multiplying that by 10 is easy. I'm just going to move the decimal point over and make it 7.660. So that's my x, this part. So my entire base, or the entire lower base here, is going to be two of those, two x's, plus this middle portion here, which is 6. Okay, so I have 2 times 7.660 plus 6, which gives me 21.32. My next job is going to be to find the height of this trapezoid. So that, excuse me. The height is, I'm going to call that y so that I don't get it confused with the measure of the hypotenuse. I still have my 40 degrees here, and y is the leg opposite from the 40 degrees. So I have sine of 40 degrees is opposite over hypotenuse, y over 10. Again, multiplying both sides by 10, I get 10 times the sine of 40 equals y. I can look up the sine of 40 now. It's 0.6428. 0.6428 times 10. I just have to move the decimal over one space, giving me 6.428. That's my y, which is the height of my trapezoid. Okay, now I can apply my area formula. So the area is 1/2 times the height times first base plus the second base, which equals 1/2 times, my height was y, 6.428 times, the little base is 6, and on the last slide I found 21.32 was the measure of the long base. So plugging all of this into my calculator, I get a final answer of 87.80 something, and we're asked to round to the nearest tenth of a square unit. So that's going to be 87.8 square units. You try this one. Use a calculator or trig table to find the area of the trapezoid. For further practice, see page 436, numbers 11 to 23, odd.